All right, so hopefully you've heard of the vertical line test too. So the vertical line test is used to identify functions, whereas the horizontal line test is used to identify one-to-one functions. For example, consider the graph f of x equals x squared. A vertical line on the graph never intersects the graph more than once, so we know that it is a function. So the vertical line test is to determine if it's a function. Then, after we know it's a function for sure, then we can do the horizontal line test to see if it's a one-to-one function. And in this case, we've already saw it in the previous example that it's not because it hits two places. The two, well, in this one, it's a little different than that, but it would hit here and it would hit here. So two different values of x give the same value for y. So vertical, make sure it's a function. Horizontal, make sure it's one to one. All right. So next, state the inverse operations for this statement. Then write a function f for the given statement and a function g for its inverse operations. So we want to multiply x by 4. All right, so we want to find the inverse operation. So the inverse of multiplying by 4 is what? Well, we're going to divide by 4. So if f of x is equals 4x, g of x is x divided by 4. So this is kind of our original function, and this is kind of the inverse of what we did here. All right, inverse functions and then how to find an inverse function. So first, inverse function. So let f be a one-to-one function, so it has to be one-to-one. Then f inverse, and this to the -1, that means inverse, is the inverse function of f if f inverse of f of x equals f inverse of f of x is equal to x. So for every x in the domain of f, and f of f inverse of x equals f of f inverse of x is equal to x for every x in the domain of f inverse. Okay, so basically what we're doing is we're plugging f of x into f inverse, and when we get out is just x. And here we're plugging f inverse into f, and what we get out is x. So if both of those are true, then they are inverse functions. Now, to find an inverse for a one-to-one function, we do the following steps. First, we let y equal f of x. Then we interchange our x's and y's. So if we had y equals 2x plus 4, then we're going to replace x and y. So this is going to be x equals 2y plus 4. Now we solve this new formula for y, and that's going to be the inverse. So if we do that, we're going to subtract 4. So we're going to get x minus 4 is equal to 2y. Now we divide by 2, and so x, or y rather, y is equal to x over 2 minus 4 over 2, or we could just put 2 in that case. Okay, so that is going to be the inverse. So that's f in, I can't write here. Let's erase all that. So f inverse of x equals y is equal to that. And this was our original f of x. Okay, so f of x, f inverse. And if we do this, what we would do is we could plug this whole thing into here, and we could plug this whole thing into here, and both ways we should just get x as our final answer. Okay, so let's try that. If we take 2 times x over 2 minus 2 and then plus 4, what do we get? Well, that's going to be x minus 4 plus 4. Those cancel, we get x. So it works taking this one, putting it into here. What about plugging this one into here? So if we do that, we have 2x plus 4 all over 2 minus 2. Well, this gives us x plus 2 minus 2. Well, those cancel and we get x again. And so because they are both x, then that really is the inverse. And again, I reduced that to 2 when I did it in the actual problem here. Okay. All right, so that's how to do inverses. So here we're going to find the inverse function of a one-to-one. So we have f of x equals 4x minus 3. So we say y equals that. Switch it to x equals the 4y minus 3, solve for y, so we add 3, then divide by 4. Oop, and they are leaving it as this. You could also, again, like I said, you could take that as x over 4 plus 3 over 4, and that's equal to your f inverse of x. Okay, so then if we wanted to think of this as a line, we had one line and this is a different line. We have different slopes, and it's opposite slope here, so that's kind of a good idea. All right, let's stop there and we'll come back for some more.